Hello again, Year 9. What we're going to do is look at some more applications. We want to get as much practice as possible with these questions because there's such a variety that we could come across. I'm going to go through three more possible examples with you today. The third one is a little bit different to what we've been doing already. It is a little bit trickier. All right, let's look at this first one then, first example. Here I've got the question. A 3-metre log rests with one end on the top of a post. You can see that's drawn in the diagram for us already, and the other end on the level ground. It's 2.8 metres from the base of the post. That's also been drawn in for us. We're asked to find the angle the log makes with the ground correct to 1 decimal place. So you'll notice that we haven't been told angle of depression, angle of elevation in this particular question, but we have been told that the angle we're finding is the one that the log here makes with the ground. So it's this one in here. What you might like to do is pause here and see if you can do the question before I do. Okay, let's start off then. I'm going to first label the triangle. This is my hypotenuse side, opposite the right angle. This is the adjacent side next to the reference angle and the right angle. I've got A and H. That's, of course, the cosine rule. So cos equals A over H. I'm finding the angle, so when I substitute, that theta there stays. And I have 2.8 as my adjacent, and then I've got 3 as my hypotenuse. Can you remember when we find an angle, we need to use the inverse cosine function? I'm going to put that into my calculator, and I get 21 point. Now have a look up here, it says to 1 decimal place. Now I've got 21.04, so to 1 decimal place, it's actually 21.0. And don't forget your unit angle, so it's degrees. You might like to copy this one down or just check your answer. Did you get the same as what I did? Let's have a look at the second one now. Here we have the angle from the horizontal of the line of sight from the end of a tree's shadow to the top of the tree is 55.2. So this is a little bit wordy, isn't it? The angle from the horizontal of the line of sight. So here's our line of sight. There's the horizontal there. From the end of a tree's shadow to the top of the tree is 55.2. The length of the shadow is 15.5 metres. So the length of this here is 15.5. I'm going to mark that in. Find the height of the tree correct to 1 decimal place. Now I can't see the right angle here yet, but I'm going to add it in because if I'm assuming that this tree is vertical, of course, if we take that vertical line there, we are finding the height, so it would be the vertical height from the top of the tree straight down. I actually have a right angle in here because there's always a right angle between a horizontal and a vertical line. They are perpendicular, so that means there's a right angle in between them. Hopefully, now you can see that I've got enough information to solve this, don't I? I've got here which side. It's next to these two angles, adjacent side. Oops. A for adjacent. This one here is the height that I'm finding. I'll call that H, and that is opposite, isn't it? You could call this X if you don't like using H because you might get confused with the hypotenuse, but I just will put here opposite. Opposite side, adjacent side. O and A, tan. Again, pause here if you want to finish it off. I'm going to substitute these values in. We have a decimal here with our angle in degrees. That's okay. We will solve it exactly the same way. Tan 55.2 equals H over 15.5. Put that into your calculator And let's round to 1 decimal place as the question has asked that. H, I've actually haven't written this in, which I should have. This is what you're actually putting into your calculator. There. And what do we get? 22.3. Now, what unit? Have a look. Meters. What I like to do is if you have a worded question, you should try and do a worded answer as well. No, I didn't do that with the one before, but let's get used to doing that now. The height of the tree. There we go. Height of the tree is 22.3 meters. Because then I've just put h in as the height, but I haven't actually specified that at any point. I've put it on my diagram here, but it's nice to be very clear what your final answer is. The height of the tree. If you'd like to put that into your book, pause here. Otherwise, let's look at the last example. Okay, this is a bit of a more challenging one. I'm going to spend some time drawing the diagram here. Let's have a look together. Read that yourselves first while I start to draw. Okay. I'm going to start entering the first piece of information. From a point A, 10 metres from a base of a tree. So this is our tree here. I'll just put the leaves on the top maybe. So we can see there's our tree. We've got a point. It's labelled as A, so I'll put that here. That point is 10 metres from the base of that tree. Here's the base of the tree here. You can put a little trunk on it if you want. Okay, so this point is 10 metres from the base of the tree. The height of the tree is given as h, so I'll put that there, h metres. The angle of elevation of the top of the tree from this point A is 36 degrees. There we go. That's the first part of the question. It gets a little bit more challenging in this second part. From a point B, x metres further on, x metres further from the base of the tree. So I'm going to mark that in. I don't know how long this is, so obviously these drawings are not to scale. But if I go an extra x metres further, okay, so this is x here, I reach point B. So from point B, the angle of elevation is 20 degrees. So I'm going to join point B to the top of the tree again. That's my line of sight from B. And the angle of elevation here is actually 20 degrees. You can see the further away you get from the tree, the lower the angle is. If you are really close to the tree here, you'll have a really big angle, your line of sight. You'll be looking up quite high, won't you? It's like when you're in the front of a movie cinema. When you're right up close to the screen, you can get a sore neck. The angle of your line of sight is increased the closer you are to the object. Okay, so we've drawn a diagram to illustrate the information given. We've got point A marked, point B, we've got X, the 10 metres, the two angles of elevation and the height of the tree. We need to find the height of this tree correct to the nearest tenth of a metre. So let's do that now. So what I'm doing is I'm looking at this smaller triangle in here first. So where I'm moving the cursor now, the smaller triangle. Okay, let's label it. I've got here the adjacent side next to the two angles. This here, the height is opposite that angle, so this is the opposite side. I'm going to do my workings down the side here. O and A is 10. Tan 36 is equal to H over 10. Therefore, H is equal to tan 36 times 10. this is what you'll put into your calculator. And if we round it off, we get 7.3 meters. Obviously, the height of the tree is in meters. Okay, what I'm going to do is, this should be in my workings. I'm actually going to use that answer there in a moment. Next, what we have to find is the distance x. We're actually finding this here, x. Pause here and have a think about how we might be able to do that. Okay, what you might have noticed is now I'm working with the bigger triangle. I'm working with that much larger one. I've got this 20 degrees here. I've also got the height. The height was this 7.3 meters. That was rounded. What I'm going to do is, instead of putting 7.3 on my diagram, I'm going to put the exact answer. The exact answer is tan 36 times 10. So I'm going to put that here. That's what the height is equal to. What I've got now is a triangle. It's got a right angle, an angle given, 20 degrees, and it's got one of the sides. It's got the opposite side. What I'm going to do is find the adjacent side here. So what I'm finding first is this whole length here. If I've got that portion, 10, and then I've got this long, I know what the whole thing is, which I can work out, I'll then be able to work out what x is by subtracting 10. I'll do that in a moment. Let's work out what this big length is here first. It is the adjacent side, okay, so we'll just label it as A again. Got O and A once more. So now, hopefully we'll have enough space for this. Tan 20 equals. My opposite side, I'm going to use the exact answer, not rounded. And the reason is I won't get as an exact, or the approximation won't be as good if I use a rounded answer. So I'm going to use the exact answer. Tan 36 times 10 is my opposite side. My adjacent side, I'm trying to find that. I'll leave that as A. Now, at this point, this is one of those trickier ones where we multiply by both sides by A, and then we divide both sides by tan 20. I might just skip a step here. I am going to run out of room. Tan 36 times 10 over tan 20 will give me this side here, A. Put that into your calculator, and what we get is 19.961, etc. It keeps going. I'm leaving it like that just until the final step. I'm only going to round at the end. Now what I need to do, I know what this A is here. I know that this length here is 10. So I just need to find x now. I've got space here, so I'm going to do my workings here, but always in your workbook, please work down the page. If I'm trying to find x, I'm going to take this whole side here, I called it A, and I'm going to subtract 10, because x here is the difference between those two lengths. You'll still have this value in your calculator, minus the 10, 9.961, etc. How many decimal places did we need? We needed it to the nearest tenth of a metre. So that's this part here, that's the tenths of a metre. So 9.9, have a look, this is going to round up. When this goes up to 0 to 10, this one also goes up. We actually go all the way up to 10, and x is in metres. That's our final answer. The value of x is 10 metres. This is a trickier problem. There are some of these that you can do for extra practice as well, which would be a really good idea. Pause here if you'd like to get those workings into your book. Thanks very much for listening.